Is that thing over there scary? Is that scary? Come on, let's go get it. Oh. I'm pretty sure it's a statue he's on.
In the next segment of your lesson video. So instead of doing a normal lesson, we're going to dive right into today's material. We're going to be talking about the Ready, Set, Go practice problem set, which you guys will be doing in groups today. During our live discussion, we have a few things to talk about. We have to talk about your enrichment projects, which I'll explain in a bit, and we also have to talk about the survey results, so you guys can be aware of what changes I made to class. So let's go ahead and get started with ready problem number 1. Is there anybody out there in this classroom who wants to do problem number 1? Come on, guys. It's not that hard.
Yo, I got this.
You guys can do it. Can I get at least one hand raise?
Right here. Pick me.
You in the back, awesome. Sir. Thank you very much for participating. I appreciate your efforts. Can you do the problem for us?
Okay, sweet. So f of n equals 5n plus 8 is our first problem that we're going to be working with. And they want to know what f of n equals when n is 4 and when n is negative 2. So let's plug it in for 4. We're going to take that 4 value and plug it in where the n is. So 5 times 4. Right, we put that 4 where the n is, plus 8. 5 times 4 is 20, plus 8 is 28. Our next problem, we're going to take this negative 2, we're going to plug it in for where the n is, just like the last one. 5 times a negative 2, plus 8, because we plugged that in. 5 times negative 2 is negative 10. Negative 10 plus 8 is a negative 2. So our first two answers would be 28 and negative 2.
That was an excellent job, man. You did everything correct. It's almost like you had the answer book in front of you. All right. Good work on ready problem number 1. Let's go to the sets group of questions and do problem number 1 there. Do I have anybody who wants to participate? Oh, Mr. Cartwright wants to participate? That's so interesting that myself would want to participate in my own class. Well, take it away, sir.
Yo, I got this recursive stuff, man. It's easy. All right. Our sequence on the next problem is 3, 8, 13, whatever. The point is we can tell that it's going up by 5. All right, we should be able to see that right away. So therefore on B, our common difference is 5. Nice work, Mr. Cartwright. All right, moving on to the recursive function. The recursive function is always going to look something like this, right? And then we have f of n minus 1. When you have the n minus 1 in the subscript, that means it is a recursive function. It should always be written like that, and I'm going to make sure on future exams and stuff that it is written like that. So if you're dealing with a recursive equation, you'll know that this n minus 1 is in the bottom. That means you take the previous step to get to the new step, right? So our first step here, so f of 1, the first step is always going to have to be defined in a recursive equation. So f of 1 in this case is 3, right? Okay, so since we know that we're just adding 5 each time, right? There's a 5 difference between the first number and the second number. We're going to add 5 right there. And this is our recursive equation. It's already all done. To find our explicit equation, we would look for our common difference again. It's 5. We're adding 5 each time, so that's going to be a multiplication by 5 in the recursive equation. So if I go over here and I have y equals 5x, That's a good place to start. I know I'm going to be multiplying 5 times x because it goes up by 5 each step. So on the first step, right, x equals 1, my correct answer needs to be 3. Y needs to equal 3. If y doesn't equal 3, then I haven't written the explicit function. So when I plug in 1 for where my x value is, I have 5 times 1, and that's not 3. How close is it? It's off by 2, right? So I have to subtract 2. Now if I plug in my x equals 1 here, 5 times 1 is 5. 5 minus 2 is 3, so I'm correct, right? Let's see if it works for the next one, right? The next step would be step 2, right, which is 8. So when we plug in a 2, 5 times 2 is 10. 10 minus 2 is 8. It works. The next step after that is 3. 3 times 5 is 15. 15 minus 2 is 13. And we have correctly solved this equation. Mr. Cartwright, in your face.
Thank you very much for participating, Mr. Cartwright. Way to go. Once again, you are correct. It's almost like you teach this stuff. We're just going to go ahead and skip and do the last section of Go. We have the very first problem to work on. So, Mr. Cartwright, can you answer it for me?
The first thing I want you guys to notice is that this is not a linear equation. It does not make a straight line. So we're going to have an exponent. However, all of this stuff should be pretty easy because we're just looking at a graph. For instance, number 12, what is Olaf's elevation at noon? We go to 12 p.m. on the graph. It looks like it is below 10,000 feet. We would have to estimate it's about 9,250 feet. When you estimate, as long as you're within the same ballpark, I don't really care. You should be closer to 10,000 than you are to 5,000 by a lot. All right. That wraps up question number 1 on the Go. Thank you.
Thank you very much, guys, for participating in today's lesson video. There's going to be a short segment about an enrichment project that is a real-life example of what I'm kind of expecting from you guys and what I can see happening for you in this project. So you guys have a wonderful day, and I will see you in the live discussion. Thank you so much. So you're going to be doing a math enrichment project this quarter, and it's going to be based off of this particular young adult. His name's Jack, and he's from Denver, Colorado. I apologize, the audio on this was really hard for me to record, so I'm just going to do a voiceover. Anyways, Jack is pitching a $5 million shared marketplace business idea to the Shark Tank. It's on ABC. It's a pretty popular TV show. Anyways, so his idea is pretty much he collects other young adults, entrepreneurs, and gives them a marketplace where they can sell their products. He takes a small stake of everything that they sell, and that's why his company was valued so highly. He's 10 years old in the video. When it finally aired, he was 11. I got to meet him when he was 13. He was talking to an auditorium full of teachers. And he's kind of the inspiration behind these projects. Thank you very much for listening. There are a few more examples, but I will tell you about them during our class discussion.